They sent them. Those people sent them. So let's quickly come to the syllabus. Make sure that all the teachers are using syllabus for you. So for maths, for mathematics, we've looked at number base, everything here. Only modular arithmetic. Only that one. That's the only thing we've not looked at. We're not planning to look at it now. Now, the next thing is to come here. I want to quickly talk about fraction, decimal, approximation, everything that has to do with those guys. That's what I want to do in today's class, hopefully. Now, yeah, when we come to the topic, fractions, decimals, so fractions, decimals, approximation, and percentages. Ordinarily, you go to a very good secondary school. I'm not supposed to stress myself on this topic. That does not mean that I'm not going to go through the topic. But like I said, I'm not supposed to stress myself on this topic. This topic, it's a compound topic, and it has 5 small topics inside it. 5 small topics. And together, those 5 topics, they form a foundation for most of the problems that you're going to encounter in other topics. So this topic is very important. I can't leave it. You might think that, have you know this thing now? You're supposed to just leave this one and go to another. Yes, I know. But I need to talk about some things here. Do you understand? So now, when we say fraction, in mathematics, we have what we call numbers. And numbers are of different types. We have what we call natural number. We have positive number. We have whole number. We have integer. We have real number. We have, let's call this rational number. We have irrational number. And like that. When we get to set theory, we are going to talk about those guys. But for now, just know that number is just something we play with in mathematics. Fraction is another thing we play with in mathematics. Fraction. When we say fraction means part of a whole. Part of a whole. For example, I bought a box of chocolates and I divided it into how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember that this chocolate is one before 1. I now divided it into 10 parts. Now the chocolate is now 10 now. Before it is 1, right? By dividing into 10 different parts. Let's assume that because me, I like chocolate very well, and I know that other people here they are going to also like chocolate. I now decide to give Rakib. This part is for Rakib. That black part is for Rakib. This yellow part is for the woman that gave birth, Nafisa. And the remaining part is for me. Me, I'm not like other tutors that like females. Me, I like males and females. So you can see I only gave that Omo 2 and I gave Rakib 3. So Rakib now has what? He got 3 out of 10. The woman that gave birth has what? 2 out of 10. And me, myself, I have what? 5 out of 10. Remember, 3 over 10 is a fraction. 2 over 10 is a fraction. 5 over 10 is a fraction. Is that clear? So fraction means part of a whole. Part of a whole. Part of a whole. This 10 is the whole. This 10 is the whole. This 10 is the whole. This one on top is the part. How many parts do I give? Am I giving Rakib in the total? I'm giving Rakib 3 of what? Of 10. When we have fractions like this, 3 over 10, this 3 has a name and this 10 has a name. The name of this 3 is called numerator. And this 10 is called denominator. Now, all this atotono, all this ejowewe is not important to us in JAM. What is important is how do we perform operations with these guys? How do we do plus, minus, division, multiplication with these guys? Operations with fraction. So I'm going to start with a question here. The question says, it's 1978 question 2. The second question you will see. The sum of 3 7 over 8 and 1 1 over 3 is less than the difference between 1 over 8 and 1 whole 2 over 3 by A 3 whole 2 over 3, B 5 whole 1 over 4, C 1 whole 1 over 2, D 0. This is a question from the fraction question. Before I quickly talk about this fraction, there's something I forgot to say, so I'll just quickly come back here and talk about it. Now, we have 3 types of fraction. Number 1, we have proper fraction. Number 2, we have improper fraction. Number 3, we have mixed fraction. When we say proper fraction, it means that the denominator is greater than numerator. The one in the bottom is bigger than the one on top. For example, 2 over 3. Another example, 7 over 13. It makes sense for a 3-year-old to carry a 2-year-old on his head. It makes sense for a 13-year-old to carry a 7-year-old. That's why we say proper. Proper. It is proper for a 13-year-old to carry a 7-year-old. All things being equal. Not that the 13-year-old is looking like a refugee. Is skinny. No. In all things being equal, the 13-year-old is looking like the way a 13-year-old should look like. And the 7-year-old is looking like the way a 7-year-old should look like. You know, there are some 13-year-old here in Nigeria. If you pick them with a 7-year-old in US, there's a big difference. So, all things being equal, ceteris paribus. So it's proper for a 13-year-old to carry a 7-year-old. In the north, there's something they call goyo. You want to do goyo? Goyo means slapping. So you just see one small boy will just enter inside keke, and the boy will stay behind in the back of that keke marwa. You know, keke marwa used to have one space at the back. So the boy will just go the alimajiri, just the alimajiri inside that keke. What is he doing? Does not have money to pay, so he just do goyo. So goyo you can lap. So you can lap. Your mommy can lap you, your parents can lap you, your other brother can lap you, your other sister can lap you. But it doesn't make sense for you to be lapping your mommy. It doesn't make sense. So that one is improper fraction. Improper now. That's when the numerator is greater than denominator. You now have 3 over 2. You now have 13 over 7 or 19 over 2. Homogeneity for 19 years. Now it's not proper. So it's called improper fraction. Now, because we do not want this 2-year-old boy to suffer, we now introduce another type of fraction that will help us ease the stress of that 2-year-old. So instead of writing 3 over 2, we like to write it in another form called mixed fraction. A mixed fraction is a combination of a whole number plus proper fraction. So in mixed fraction, now you'll be seeing something like 1 whole number 1 over 2. We have converted this guy because we want to help this guy. If you leave that 3 over 2 in your notes till the next day, it will become 3 over something like this. The 2 will be tired. It become 2 for the next again to become something like this. Imagine. The 2 is very, very tired. Because you want to help that 2, what do you do? You convert it. 2 is the command. Remainder 1 over 2. So we can convert this 13 over 7 also. This is what I'm doing now. You can convert this 13 over 7. How many 7 can you see in 13? 1. Remainder 6 over 7. Can help this 19. So how many 2 can you see in 19? Times 9, 18. 9, remainder 1 over 2. So we've converted these guys to what? To mixed fraction. Good. Now let's come back to class. So we have these 3 types of fraction. Now this question says the sum of 3 or 7 over 8 and 1 or 1 over 3 is less than the difference between, we are going to get there is 2 things embedded in each other. So the first thing we have to do is we have to look at the sum of these 2 guys. It says the sum of 3 whole 7 over 8 plus 1 or 1 over 3. If you add them together, it is less than accuracy, the difference between these 2 guys. By what? That's what we are asked to find. So let's find the sum of these 2 guys. Then we find the difference of these 2 guys. They will now bring them together as one question. But the first thing is that we have to add these 2 guys together. That's the first thing we have to do. Now, this has lead us to one phase of what we want to look at, operations in fraction. We want to look at addition of fractions. Can you all hear me clearly, please? You can't see me. Now, to add fraction or to subtract fraction, they are the same thing. In fact, I had a video on YouTube on how to add, subtract, divide, multiply fractions together. You may want to sit down and look at it. But again, I'm just going to explain in brief because you're expected to know this one. It's not something I'm supposed to dwell much on. But don't worry. Even if you don't know it before, if you listen now, you understand it. Rules of adding and subtracting fraction. If you are in this class today, and if you see 2 over 3 plus 1 over 7, and you do 2 plus 1, 3, 3 plus 7, 10, know that you have a lot of work to do. Just know that. Do you understand? That does not mean that you cannot score 300. If you are ready to work, you can still score 300, even more than that. But if you don't know it and you're still lazy and you're not even ready to work, in fact, to score 200 is going to be wow. So if you don't know this before, then it's not a problem. Like I said, don't worry, you will know it. To add fractions together, you can't do this lie. Nowhere in the world can you do this. Nowhere in the world. Because 2 over 3 is like saying I have something like this. And I want to add it to I have 2/3. This shaded part here. I want to add it to 1/7. I want to add these two guys together. The first thing I have to do is I have to ensure that this division is the same. I have to find a way of taking them to the same division. 3 and 7, they must have the same denominator. That's the first thing. So the way they will now have the same denominator, it will depend on the kind of denominator they have. So rule number 1, if the denominators are different, multiply them. In this case now, 2/3 plus 1/7. The denominators are different. 3 is different from 7. What do? You multiply 3 and 7 together. So 3 times 7 is what? 21. So your new denominator is going to be 21. How many 3 can you see in 21? It will be 7. So just do 7 times 2, 14. Plus, how many 7 can you see in 21? It will be 3. 3 times 1, 3. So this fraction, if you add 2/3 plus 1/7, you're supposed to get 17/21, not 3/10. That's it. If you don't understand this one, let me explain sharp. If you don't understand, should I explain again? No, but you cannot hear me. Okay, thank you. At any point, if you don't understand anything, the beauty is that nobody can even see you. Nobody knows you. So just quickly tell us if you don't understand. Nobody, in fact, I might have passed through some of you that we are even teaching. I don't even know you are the person. Only you that know me. You understand? That's one of the beauty of this class. So if you don't know something, just stop. Just give me thumbs up. Just give me thumbs up. Nobody will see you. Now, I have 2/3 plus 1/7. We want to add these two fractions together. I already made it clear that you cannot add fraction by saying 2 plus 1/3 plus 7. Where I'm 4 is sharing 2 plus 1, 3. 3 plus 7, 10. Then 1 for one according to simple or doing. So even when you see your score, when you see that damn score, you know that you cannot recharge anything as it. So 2 plus 1, 3. 3 plus 7, 10. It's not possible. You can't add fractions like this. So what do we do? The only thing we can do is to find LCM. We need something called LCM, which is called lowest common multiple. These two denominators, 3 and 7, we have to make one number that 3 will divide, 7 will divide. That's LCM. So you have to pick a number that both denominators can divide. Do you understand? So you need a number that both denominators can divide. How can we get the number? Now, the rule number 1, if the denominators of the denominator. So in this case now, 2/3 plus 1/7 now. The denominators are different. So we multiply 3 times 7. How many 3 can you see in 7? Sorry, how many 3 can you see in 3 times 7? Let me just make the answer. The LCM now is going to be 3 times 7, which is what? 21. So you put it here, 21. Now, how many 3 can you see in 21? It will obviously be this 7. So 7, that's 7 times the numerator of this fraction you're working with first, in brackets, plus how many 7 can you see in 21 again? That will be 3. Then 3 times the numerator of this one you're working with now, 1. So 7 times 2, 14, plus 3 times 1, 3 over what? 21. So 14 plus 3, 17/21. That's the first one. The second one, example 1. Example 2 now. I have 7/9 plus, let's see, 4/9 plus 2/9. What do you observe here? The denominators are the same, right?
Yes.
So rule number 2, if the denominators are the same, comma, pick one, add numerators. So in this case now, the denominators are the same. What do we do? We're just going to pick one, 9, and we are going to add the numerators, 4 plus 2. That gives us what? 6/9. And you have to take it to the lowest term because 6 can divide 9. 3 can go in 6, 2. 3 can go in 9, 3. So our answer is what? 2/3. Do you get it? If you know this rule alone, it suffices. But let me give you number 3. And maybe I'll give you number 4. Number 3. I have 3/8 plus 5/2. Now, example 3. Let's make this example. Rule number 3. If the denominators are different, they are different, right? As you can see, it's different from 2. But one is a multiple of the other. Eight is different from 2. Yes, but 2 can go in 8. Because if you read the multiplication table 2 times 100, you can see that 2 falls in the multiple of what? Of 8. What do you now do? Pick the big guy. Put the greater number as a denominator. So now, if you want to solve 3/8 plus 5/2 now, your LCM is going to be what? 8. Why? The denominators are different, yes. But one of the number is a multiple of the other. It means that one number can go in the other number. So pick the big number, 8. So how many 8s can you see in 8? 1. 1 times 3 in one bracket plus how many 2 can you see in 8? 4. 4 times 5 in another bracket. 1 times 3 is 3. Plus 4 times 5 is 20/8. So 3 plus 20, that's 23/8. Let's look at the last one. The last case that you can have. Example 4. I have 5/6 plus 2/9. This one now, it makes sense. You can see that 6 and 9 are not the same number. 6 is not a multiple of 9. 6 is a multiple of 9. No, it's not. But it has a common factor. So this rule number 4 is if the numbers are different, but they both have a common factor. Remove the common factor and multiply what is left with the common factor. You understand this now what I do is. Now, 6 and 9 are not the same thing. Are they the same thing? No. But they have a common factor. What do you mean by common factor? There's a number that can divide 6, divide 9. Hold on, 3. Remove 3 from 6. Remove 3 from 9. If you remove 3 from 6, you have 2 times. If you remove 3 from 9, you have 3. Now it says remove the common factor. I've removed the common factor from 6. I've removed the common factor from 9. Now multiply what is left with the common factor. So 2 times 3. 2 is left from 3 divided by 6. 3 is left from 3 divided by 9. Now multiply this 2 and 3 by what? The common factor. So my LCM is going to be 2 times 3, 6 times 3, 18. My LCM is 18. You get it? If you don't understand it, don't stress yourself. There's another thing you can do, even if you don't do all this one. I just want you to know what you're supposed to do. So to solve that question now, 5/6 plus 2/9, the LCM is supposed to be 18. But even if you still use the idea that 6 times 9 will give us what is 6 times 9? 54. Yeah, 54. Even if you use the idea that 6 times 9 will give us 54 and still solve it, you are still on the right track. You understand? You are still on the right track. Now, how many 6 can you see in 18? That's 3. Because 6 times 3 is 18. So 3 times 5. Plus how many 9 can you see in 18? 2. 2 times 2. So what is 3 times 5? 15. Plus 2 times 2, 4 over 18. That is 19 over 18. And you can write it as 1 number 1 over 18. We just look at how to add and subtract fractions. The same thing we do when we add fractions is the same way we do when we subtract fractions. You understand? It's the same thing. Don't stress yourself. It's the same thing. The same way we add fractions, the same way we subtract fractions. So there's nothing really special in here. Now, we've gotten 1 number by 18. So we've done all the ways to what? To add and subtract fractions. Now let's come to this question. This question here says the sum of 3 wholes 7 over 8 and 1 whole 1 over 3 is less than the difference between that. So I want to focus on this first. This part that says that the sum of, I want to focus on this first. I want to get that sum. Now, let's add these two guys together. Now, we can add it by doing, add the whole numbers, do 3 plus 1 separately like this. Plus, then do 7 over 8 plus 1 over 3 like this. It's possible. So the LCM, yeah, is going to be what? 24 because 8 cannot go in 3. There's nothing you can do. It's just the first row. 8 times 3 is 24. So how many 8 can you see in 24? It will be 3. 3 times 7 plus, how many 3 can you see in 24? That's 8. 8 times 1. Don't forget that we have 3 plus 4, 1 here, which is 4. So we have 4 wholes. 3 times 7, 21 plus 8 over 24. That gives us 4 whole. 21 plus 8 is going to give us 29 over 24. Now, we can't have 29 over 24. That's an improper fraction. So we have to say, how many 24 can we say in 29? 1. That one will come and meet this whole number 4. It will be 4 plus that 1. So when you remove 24 from 29, you have a remainder of 5 over 24. So that gives us what? 5 whole number, 5 over 24. Method 1. Let me write it here. Method 2 is that you can decide to convert 3 whole number, 7 over 8, plus 1 whole number, 1 over 3. Convert it to improper fraction. How do we convert? Very simple. 8 times 3, 24. 24 plus 7. That's 31 over 8. Plus 3 times 1, 3 plus 1, 4 over 3. Just do this times this. Whatever you get, add it to 7. This times this, whatever you get, add it to 1. If you understand. So it still falls to the same thing. Our ICM is going to be 24. How many can I see in 24? 3. So that will be 3 times 31 plus, how many 3 can I see in 24? 8. 8 times 4. So 3 times 31 is going to be 93 plus 8 times 4 is going to be 32 over 24. That gives a 125 over 24. So how many 125 can you see in 24? It's so obvious. It was 24, man. 525 will give us 125. So it means that we have 5. Remainder 5 over 24. And that's the answer. That is adding those two guys together. So you can use method 1 or method 2. Anyone you prefer. Anyone you feel that is simple. Anyone you feel that is simple. And use any method. Now that's the first part of the question. The first part of the question says the sum of 3 whole 7 over 8 and 1 whole 1 over 3 is less than the difference. Now let's focus on the difference between 1 over 8 and 1 whole number 2 over 3. 1 whole number 2 over 3 minus 1 over 8. It says difference. Difference is another name for minus in mathematics. or subtraction. So difference. Sum is another name for what? For plus. Difference is another name for what? For minus. Now, the difference between this and this. So it will most likely be this minus this. That's how I wrote it. 102 over 3 minus 1 over 8. Is that correct? So again, let's look at this. We can use 3 times 1, 3 plus 1. That's 5 over 3 minus 1 over 8. If you take the LCM, you have 24. 3 in 24, 8. 8 times 5 is 40. Minus 8 in 24, 3. 3 times 1 is 3. That gives us a 37 over 24. So we can see one whole number 13 over 24. That's the difference. Now, the sum of this x plus y is this. And the difference of y minus x is this. The question is now saying that this, it says, that sum is less than the difference by what? So we need to look for the difference between these two fractions. So we need to do 5 whole number, 5 over 24, minus 1 whole number, 13 over 24. And I'm going to use two methods. The first method, 5 minus 1. So that's what we might now seen before. 5 minus 1 into bracket 5 over 24 minus 13 over 24. So 5 minus 1 gives us what? It gives us 4. Now here, LCM is the same thing, 24. So just pick 124 and subtract 5 minus 13. That gives us 4 number. 5 minus 13 is what? Minus 7 over 24. Don't lie, yo. In this mathematics, 5 minus 13 is not impossible. Like the one you do. Don't lie, yo. It's minus 7. Now, where we got to here now, there's a big problem. And to solve that problem, we have to remove 1 from this 4. This 4 will now become 3. That 1 that we removed, we are not going to write as 1. We are going to write as 24 over 24. Hey, wahala. 24 over 24 is the same thing as 1. Because we are dealing with fraction 24 here, that's why I say we should bring 24 over 24. Is that correct? So minus 7 over 24. Now you can work. 3 whole number, LCM is 24. If you remove 24 minus 7, you get what? You're going to get a 17. That's 3 whole number, 17 over 24. Is it there? No. So what is 24 minus 7? There's a mistake somewhere.
Okay.
5
5
minus
minus 13 should be 8.
Thank you. That's what you can see. Thank you. Only the guy is following. 5 minus 13 is 8. So 8 over 24. 24 minus 8 is going to be 16 before. So it's 1 divide. So we have 3 whole. 4 here. 4 can go in 24. 4 go in 24. Okay, so 8 can go there. 8 here, 2. 8 here, 3. So over 3. So that's the answer. 3 whole number. So over 3. Option A. You will not be saying that, and they are going to ask us to do this question in 1 hour, in 1 minute. How come it's possible? If you know your way around this question, because I'm trying to explain everything that has to do with fractions, that's why we are spending a lot of time here. Do you understand? The second method we could have used here is to convert 24 times 5. That's 120. 120. We did that other time now. We convert it back. What's it? 125 over 24. 125 over 24 minus 37 over 24. The improper, I'm not bringing this guy and this guy together. So let's subtract them. My LCM is going to be 24 because they are the same. So I'm not going to pick one and subtract. 125 minus 37. 125 You are going to have calculator that day, but I bet that you might even not want to use calculator that day because the price is even a problem. So year 1, year 15, that's 8. Year 0, year 11, that's 7, 8, 9, 10, 8, 88. So 88 over 24. Let's bring out our sword and divide. For 8 year 11, 8 in 24, 3. How many 3 can you say in 11? 3 times. 3 times 3, 9, 10, 11. So 2 over 3. And that's the answer. So I think this one is even better than going through this route. 3 over 2 over 3. So I believe that I've been able to discuss everything that has to do with addition and subtracting fractions, right? Excellent. And we've looked at how to convert from one fraction to another. We're going to see questions. Okay. Another interesting question that is often seen is arranging fractions. Before I even go to arranging fractions, let me quickly talk about multiplying and dividing fractions. Multiplying and dividing fractions. If I have 2 over 3 times 15 over 4. To divide fraction is very simple. Dividing fraction is very simple. Sorry, multiplying fractions. It's very, very simple. In fact, it's the simplest. Just do numerator times numerator over denominator times denominator. Unlike addition and subtraction, like you cannot add. You have to look for LCM. For multiplication, you can multiply together. So we can do 2 times 15 over 3 times 4. And they are very good. You know how your way around using sword very well. You can cut 2 year 1, 2 year 2, 3 year 1, 3 became 5. My answer is 5 over 2. But some people don't even like all these things. It confuses them. No problem. Just do 2 times 15 over 3 times 4. 2 times 15 is 30. 3 times 4 is 12. And you cannot divide. 2 goes in 12. Sorry, even 6 can even go. 6 goes in 12 2 times. 6 goes in 30 5 times. So we have what? 5 over 2 as our answer. That's how you multiply fractions. Very simple. Now, let's take a look at how to divide fractions. To divide fraction, let's say I have 2 over 3 divided by 4 over 15. Or I have it like this, 2 over 3 divided by 4 over 15. The same thing. Either this division like this or this division like this. There's something I have to say here. Let me come back to the division. I'll come back to the division. Let me say something. Let's say I have 2 over 3 times 6 fraction with a whole number. Can you all hear me, please? Can you all hear me? Good. Let's say I want to divide a fraction with a whole number now. 2 over 3 times 6. It's very simple. Just put over 1 here. Introduce over 1. This one that you introduce here is called understood 1. I have a video on this on YouTube as well. Understood 1. We know that it's here, but we don't normally write it. If you attend madrasa, there's something in Arabic that they say tuntok wala tuktab. We say it, but we don't write it. Or tuktab wala tuntok. All those things in Imla, Arud, and all of that. So it's also similar. So this one, we know that the one is here, but we don't normally write it. So you can bring it when you need it, so that it will make this thing easy for you to do. Because some of you will just get confused that hey, Bola 56 is Sibai. Bola 56 is Sibai. So nobody is calling me shake out that. We are going to now. So about 3 times 6. The way we do it is you have to introduce that one, that understood one. We know that it is there, but we do not write it. We bring it when we need it. So now we can now easily do 2 times 6 over 3 times 1. And we now have 12 over 3, 3 over 1, 3, 12, 4. Still the same thing. And if you know your way around it, you don't need to put that over 1 there. Because some of you will be asking me, this 6, is it for the numerator or denominator? It gets confusing. So no problem. In fact, can I write this over 3 times 6 and what cost time? Everything color new to be well is on top. So just say 2 over 3 times. I think I can on the top. Don't worry. Can you say that this call? Ah, let's see. Oh, I'm sorry. Can you now hear me? Am I audible now? Am I audible? Oh, Alabama, sir. The network just decided to play identity lost. Okay. Now, let's come to division of fractions. We have 2 over 3 divided by 4 over 5. It can be in this form or something like this. If it is in this form, don't stress yourself. Then this big function like this and do 4 over 50. Anytime you see division, in fact, I so much love the students because they tell me when the network is good and when it is bad. Can you now hear me? Can you hear me? Can you hear me? Can you hear me?
Yes, sir. Yes, sir.
Thank you so much. Now, anytime you see division problem like this, don't stress yourself. Don't stress yourself at all. In a case where you have division like this, don't forget KCF. 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 How many of you have been to KFC before? If you are from Edo, don't raise your hand, please. Please. If you are from Edo, don't raise your hand. And if you are from Akure, don't raise your hand. Please. Please. Aisha, please. Don't raise your hand. You have been to KFC before, please. Thumbs up, please. KFC guys. Okay, even if you have been to KFC before, there's one that you have not been to. Who has been to Mike before? There's one very, very good. It's my network now. Is it my network? That's what I think. Is it network?
Yes, sir.
No, wahala. Is it better? Huh? Oh, so if you have been to KFC before, you easily remember KFC. That chicken and there's one in Kano, Albeik. Now I'll bake is very sweet also. Very sweet. I'll bake. When I have a poultry business, I also start frying chicken, but I'll eat it first. I'll eat all the chicken first. So why am I asking you to remember KCF? This K stands for keep. This C stands for change. This F stands for flip. You see this first guy, you are going to keep it 2/3. This second guy, this sign, you are going to change it to multiplication. And this 4/15, you are going to flip it to 15/2. That is KCF. Keep, change, flip. Keep, change, flip. I want somebody to type that in the chat. Keep, change, flip. Keep, change, flip. Keep, change, flip. Keep, change, flip. Thank you. Good. So with this now, you can go ahead and do whatever you want to do. It's 5/4, 15/4, not 15/2, 15/4. Yeah. Then you can do your normal multiplication that we just did. Do you understand? So it's very simple. Times 15 is 30, 3 times 4 is 12, 6 and 12 is 2, 6 and 30 is 5, and we have 5/2. As simple as that. So when we see a division question, now we know exactly what to do, right? Good. Thank you. So we've looked at all the operations it was with fraction. Very simple, right? Very simple. Now let's look at some complications. How JAMB set questions around this. In fact, on this topic alone, I have wow. I have 81 questions. 81 questions.
So I have a question.
Go ahead, please. Go ahead.
So the question you just solved now is 2/3 divided by 4/15.
Yes.
And we know 4 is the factor of 2 and 3 is the factor of 2.
Yes.
Perhaps if we divide it straight like that and we eventually find the answer in the option, is it advisable to pick the answer or we should flip it? Is it something that we must do? That keep, change and flip. Is it something that we must do if we come across such question?
No, it's just a way for you to. It's just a way to code the answer, like to code the step. It's not necessary that you have to do it. No. In fact, even if you know your way around mathematics, you can manipulate this one here, this compound fraction. The way you can manipulate it without doing these things. You understand? So let me show you that because you asked 2/3 divided by 4/15. This compound fraction now. The way we do it is it's going to become something like this. How I do it. So this is numerator, denominator, numerator, denominator. So 3 times 4, 12. That will be the denominator. Sorry, not 15, 12. Then 2 times 15, that will be 30, numerator. You see that? You're starting with this one, sir. You're starting with this one. Whichever one you are marrying with this n, you know you start with. You see that?
Yes, sir.
If you're going around compound fraction, you can do it like this. Very easy step. Start with this numerator. Take it with the numerator down. That's 30. Then the denominator, start with this numerator, and you bring 12, 3 times 4, 12. Do you get it? So you already
Yes, sir.
like that.
Yes,
You flip it already. Thank you for that contribution. So under fraction, decimal, approximation, and percentage in Jambremix, we have 147 questions. 147 questions. The past question I'm using for you is not Jambremix. It is something that looks like Jambremix. There, they have 88 questions, and we are going to solve all the questions. Those 88 questions are inside that 147 question. Yes. So I don't solve everything. I don't solve everything. That's the purpose of teaching you now. So that we can solve everything. So let's come here and see the way Jam would ask you some questions. Jam would throw questions like this. Rearranging now. That's a subtopic. Rearranging. Don't mind English. My English. This is not English class. So please bear with me. 3/5, 9/16, 34/59, 71/97. As simple as this question is, I beg you, please use your calculator. Just take it to decimal and tell me the answer. Don't stress yourself, please. This question says, it says arrange these guys in ascending order of magnitude. Now let's quickly talk about ascending and descending. When you ascend, you are going up. Higher, higher. When you descend, you are coming down. You are coming down, just like decrease, reduce. So ascend means according to your gogorungu. You know, if you attended a school where you do assembly, you understand what I'm saying. The way we stand during assembly is according to our height. So ento kereju, followed by ento gatele, ento gatele, ento gatele, ento gatele. But this is not how soldiers like to stand in military form. They don't like to stand like it. They like to flank. Don't worry, when you join the military, you understand what I'm saying. So ascending and descending. Ascending means according to your gogorungu, boshegasi. Descending means start with the tallest person, then come down, descend. So if people stand like this, if you look at them from here, they are ascending. But if you look at them from here, they are what? They are descending. Do you understand? From the back. So ascending is you are going on over a staircase, you are ascending. You're going to start from the smallest, the lowest step up to the what? The highest. If you are descending, you are going to come from the highest staircase to the what? To the lowest. Do you understand? So ascending and descending. So what you want to do here is just press these guys in what? Don't stress yourself, please, please. I'm begging you. I'm begging you. Don't try to use any method. The simplest and the easiest method is to take it to decimal. Please, I'm begging you. I'm begging you. There are methods to solve this question. Yes, I know, but don't try it in UTME. Don't try it, especially when you see big numbers like this, 9759. Don't do it. Don't do that method that you think, okay, method you can lesson. Job is not about method. It's not about method. They give you 2x2 matrix to solve. You are not using Sarusu. When there is easy block and multiply method, don't try it. So it's not about method. Yes, there's a calculator in exam. Someone is asking me, now we going to use calculator in exam. There's a calculator in exam. But the calculator you can use in exam is another calculator. Okay, let me do something. Non-scientific. Yowa. Yori. Once it download, this is what we'll be using to practice yourself now. So you guys can acclimatize to it. There's no sine, there's no cosine, there's no tan. You don't have choice. So when you see cos 60, you now be saying, well, this number are very stupid. That there fed us with no cos 240. When you did not stay in math class, you don't know how to use quadrant to do it. Imagine. My students are going to enjoy. Yeah, I think it's going to be very easy. Okay, as you are expecting this one to download, network is very poor. Let's come back to class. So if you put all these guys in this thing for me, please let me know. If you have the decimal of these guys, please let me know. Please drop the decimals in tabs, please. So 3/5 is what? 3/5 is 0.6. 9/16 is 0.56. 34/59 is 0.58. 71/97 is 0.73. There's a method you can use, but don't stress yourself. Just take it to decimal. It's the fastest. JAB is about being smart. It's about being smart. We Muslims, we have a role model, and our role model is the Prophet Muhammad Sallallahu Alaihi Wasallam. If he has two options, what option does he pick? He pick the easiest one, the easiest, provided that it has no sin attached to it. Are we together? So in this case now, if you arrange based on this, it means you are going to pick what first? 0.56 first, then 0.58, then 0.6, then 0.73. 0.58 is 9/16, 0.58 is 34/59, 0.6 is 3/5, 0.73 is 71/97. Don't forget, like I said, JAMB is not about method we do. It's about using the fastest method. Can you all still hear me? Excellent. 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 Thank you. 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 We have few time left. Let's take one question so that I can introduce what is remaining for me to talk about. Now I have to talk about order of operation quickly. So this is where we are going to spend a lot of time and a lot of examples. You guys are going to see questions like that, and you're going to pee your pants. Ha ha ha. You think that that normal maths that you do in secondary school. This question, you can see a question here and you'll be frustrated. Yes. Why do you think that JAM has 140 something question on this topic? As simple as it is. As simple as it is. 140 something questions. And mind you, they are not child questions. They are not silly questions. They want to test something. They want to test something. So this question we just solved here. So there's a question here we have to simplify. It says, okay, order of operation. So in mathematics, every one of you know this thing, board mass. So I'm going to change it. I'm going to change it to you can see the way I wrote it. I'm going to change it to PEMDAS. P stands for parenthesis. E stands for exponent. M stands for multiplication, which you can also call off. D stands for division. A stands for addition. And S stands for subtraction. Now, what does this mean? This is telling us that in mathematics, when you have numbers, cluster of numbers, or fractions, or decimals, and you have numerous signs, brackets, exponents, power, multiplication, how do you solve it? How do we expect you to solve it? We expect you to follow a particular order. That order is the standard order that all mathematicians follow. And that order is what I have on my screen. Now, for multiplication and division, you do whichever one you see first from left to right. For addition and subtraction, you do whichever one you see first from left to right. Is that clear? So we can change them. They are changeable. But apart from those two, you have to do the bracket first. You have to do the exponent first. Do you get it? So when we see questions, you see the way I apply them to solve questions. So I have 2 whole number 5/12 minus 1 7/8 times 6 over 5. This one is not even complex. Very simple. You have to do the bracket first. Why? Because of the parentheses. Parentheses means bracket, too, guys. Exponents, it means power. Raised to power. For example, 2 raised to power 3. And this is an exponential number. So in this case, just convert everything to improper fraction. 12 times 2, 24 plus 5, that's 29 over 12. Minus 8 times 1, 8 plus 7, 15 over 8. Times 6 over 5. Please, for Allah's sake, don't remove the bracket. Please. Don't remove the bracket. You have to solve the bracket first. So 29 over 12 minus this bracket. Now you can divide whatever you feel is dividable. 5 here 1, 5 in 15, 3. 2 here 4, 2 here 3. 3 times 3, that's 9 over 4. Then you subtract. LCM is going to be 4. Why? 4 can go in 12. Can you see that? So that's 29 minus. How many 4 can you see in 12? 3. 3 times 9, 27. 4 29 over 27, that's 2 over 12. And that's 1 over 6. Is that clear? We have 1 minute left for the class, so I'll solve just one more question and we'll continue from here in the next class. So that looks just like this. So the remaining thing is just to solve question. There's one question. I will not solve the question, I'll just write it for you to see. 1 over 2 plus 1 over 2 plus 1 over 2 minus 1 over 4 plus 1 over 5. Let me take it. 1985. And that's what the question, and I'm happy. Okay, if you think that you know math, try it. Damn, it's crazy, man. This question I even meant. There's another one in 1981, question 46. In fact, that 1981, 2 questions came on this topic. There's one in question 43 and question 46. Question 43 looks like the first question we solved. The difference between 4 number. So don't worry. There are so many questions. Like I told you, you see question and you fear your body. But before then, one question I saw now, I can't even find it. Okay, yeah. Simplify. Don't worry, I'm not scaring you guys. But everything has step. So we've looked at the first step. The first step is to, like I used to tell you guys, mathematics is not about how many we've done topic A, we've done topic B. How many questions have you solved? That's mathematics. That's mathematics. Mathematics is just like an art, any art subject, any art, like maybe you know how to do lali or you know how to cook very well. There are some people that they are so perfect in cooking to the extent that if you ask them to prepare food for 4 people, they know the exact quantity of water they have to put in the fire. That's how perfect they are. They will not add or reduce from that water. My time is going to go up in 2 minutes. So I think I have to end the class now. So this question is very simple. Very simple. This one I have here is very simple. Everything is just plus. So I'll see you guys in the next class. Thank you so much for your responsiveness.